Dear student, due to coronavirus, school started online classes for your study. So you can subscribe Golden Flower Palia YouTube channel, like and press the bell icon.
Hello students, we are going to start the next module of the chapter that I taught you last, that is error analysis. Okay, in this chapter we have studied accuracy, we have studied precision, we have studied errors and the type of errors, out of which I have been explained to you what is systematic error and their classification. In this module we are going to discuss a random error. It was the second number, random error. Okay, and third we are going to discuss least count error, and fourth we are going to discuss gross error. Okay, and here we, in this module, we are going to discuss about how to eliminate random errors and some of the terms that comes in the elimination of random errors. Okay, so some of the part we are going to discuss today of errors, and out of which I am going to explain you now random error. Okay, you know the meaning of random. Okay, so errors, random errors means the error which are occurring randomly in the experiment. Okay, so what will be the definition of the random error? The errors which occur irregularly in the experiment in magnitude or direction. Okay, so errors which occur irregularly in the experiment in magnitude as well as in the direction. That means there it is no particular direction, there it is no particular magnitude. They occur randomly, like a housefly is moving around without any particular direction. Its motion is random motion. Okay, similarly when we are performing an experiment in the lab, sometimes some errors occur, like you are taking observation of an experiment, and every time when you are experimenting with the same procedure, with the same instrument, but you are getting the different readings, you are getting different observations. Okay, like I'll explain you with an example. Like I have given you a convex lens and an optical bench to you. Okay, and you are going to experiment with this optical bench and the same lens. So every time when you will perform with the same procedure, with the same optical bench, with the same lens, you will get the different focal length of that lens. Okay, so here these are the errors. Every time when we are experimenting, we are getting the different observation. It means some errors are occurring, but the exact what is the reason behind this error, it is unknown. Okay, so that is why we are calling these errors as random errors. So what is random errors? Which occur randomly in the experiment. You can write that also. So what is random error? Random errors are which occur irregularly in the experiment in magnitude and in any direction, in any random direction. Clear? So after random errors, we must be knowing what is the cause of random error. So here I am writing the cause. Okay, it is not the exact cause, but then also it can be. Okay, it's our prediction. What can be the reason of the random error? So it can be, it causes due to slight change in the attentiveness of observer. Okay, whoever is observing this experiment, maybe he is not attentive anymore. Okay, so that can be the reason. And another, it can cause or due to slight variation in experimental condition. Okay, it can be due to the slight change in experimental condition. Likewise, you are doing some practicals in the lab. Every time the temperature will not be same. Sometimes it will be 25 degrees Celsius. So maybe the conditions are getting changed. Experimental conditions are not the same. Like you are doing some practical with the electricity. Okay, every time 220 volt will not come. Sometimes it will be 230 volts, sometimes it will be less also. Sometimes the current will increase, sometimes current will decrease. So when there are slight change in the experimental condition, the errors are occurring. Okay, when we are performing the experiment in the lab, we always face this problem. Sometimes the reading comes at 50, sometimes the reading comes at 60, sometimes it comes at 55. So these slight changes are coming due to the change in experimental condition, variation in experimental condition, because we cannot give the constant condition to the experiment. Is that clear? So what are the random errors? Actually, random errors are the error which occur irregularly at random in magnitude as well as in the direction, and the cause, it can be due to the slight variation in the attentiveness of the observer. Maybe the observer is not attentive, or it can be due to the variation in the experimental condition, because the experimental conditions are not same as the time is passing. Okay, so this I think you have understood what are the random errors. We will talk about the elimination of the random errors in next topic. Okay, after explaining the least count error and gross error. So let's see what is the least count error now. Least count error. If I ask you a question, what is the smallest value, smallest length that you can measure with your scale? Your answer will be the small division of your scale, that is 1 millimeter. Okay, so 1 millimeter is the small value that you can measure with your scale. But instead of that scale, normal scale, we are taking the vernier scale. Now what length we can measure? Now what diameter we can measure of a thing up to smallest value? Which smallest value? That is 0.1 millimeter. If instead of taking the vernier scale, we take screw gauge. So in screw gauge, we can measure 0.01 millimeter. It is the smallest value. So what this smallest value tells us? The smallest value tells us this particular instrument cannot measure the thing below this particular value, below this value, the smallest value, and this smallest value is called least count. So of your scale, the least count, it is 1 millimeter. Of vernier scale, the least count is 0.1 millimeter. Of screw gauge, the least count, it is 0.01 millimeter. So these are the least count. Least count means the minimum value which can be measured by this particular instrument accurately with full of accuracy. But below this value we cannot measure. If someone asks you to measure the length of a line 0.1 millimeter with a normal scale, so it is not possible. Okay, so this is the error condition. That means this is smallest value. Below this smallest value an instrument cannot measure the things accurately. So this error occurs in some of the instrument that we are taking in our experiments. So what is the least count error? Least count error is the least count, the smallest value up to which the instrument is accurately measuring the things. Okay. So what is least count error? It is smallest value that an instrument measure accurately. Okay, I think you understood very well. If you are having particular type of instrument and its least count is some value, below that value you cannot measure with that instrument. So you have to take more precise instrument for measuring the things below that value. Okay, so this is the least count error. Now what is the gross error? What is the gross error? Errors occur due to carelessness of observer. Okay, let me explain you with an example. Okay, suppose you have drawn a line on your copy. Okay, and I have given you a scale to measure this line. So you are putting the scale on that line and you are observing the length of line from any one of the side, like from left hand side or from right hand side. So when you are observing from the right hand side, right of mine, okay, from my right, so then you will see the length of line. Suppose the length of line exactly it is 5 centimeter. If you are looking, you are observing the length of line from the right of mine, okay, from my right side, you will observe that the length of line it is 4.9, 1 millimeter less. If you are measuring the same line from the left of mine, from my left side, you will see that the length of line it is 5.1 centimeter. This you can observe at your home also. Okay, you draw the line of 5 centimeter and observe that line from the left hand side, from the right hand side. You will see that there will be a slight difference in the length of line. Okay, but if you see at the center of the scale, at just above, correct, the eye position should be correct above, normal to the line, just above the line you will see that it is 5 centimeter. So there should be the correct position of the eye to see the length of the line. So this is called the carelessness of the experimenter. So whenever the experimenter is doing an experiment, observing the reading, maybe his position of the eye is not correct. Okay, maybe the way he is observing the readings, it may not be correct. Okay, so this can be the reason of the gross error. Clear? So by correcting the position of eye, by correcting the procedure that you are following, you can eliminate the gross error. Least count error you understood, gross error you understood, random errors you understood. Now we are going to explain going to study how to eliminate random errors. Okay. I am going to explain you how to eliminate random errors. Elimination of random error. Okay. You might have seen when we are experimenting with an instrument, same procedure we are following 6 times. Okay, and we are finding 5 or 6 observation of the same experiment. Why we are doing so? Why we are taking so large number of readings? Okay, because this is the way by which we can eliminate the random error. How the random errors are eliminated? By taking the large number of readings and their arithmetic mean. Okay, so random errors can be removed. Random errors can be removed by taking arithmetic mean of large number of readings, observations of an experiment. Okay, this is the way of removing the random error. We have to take large number of readings and we have to take arithmetic mean of that readings. Likewise, you are experimenting with a lens and finding the refractive index of the material of lens. You have to take a large number of reading, like 6-7 times you have to experiment with that lens and have to find out the different observation that you are getting in the experiment. After taking that experiment, after taking that observation, you have to find out the arithmetic mean of that observations. So whatever the value will come after the arithmetic mean, the arithmetic mean of that observation is called true value. We can consider it as true value. So what is true value? True value, here it is, the arithmetic mean of large number of readings can be considered as true value. Okay. So this was the elimination of random error. On the basis of this method, I am going to explain you some more terms which are related to the errors. Okay. Here I will explain you what is true value, what is absolute error, what is mean absolute error, what is fractional error, relative error we call it, and what is the percentage error. So here I am going to explain you with an experiment how to remove the random errors. Okay, and we are taking an example of derivation kind. Okay, a derivation we are taking, and I'll explain you some of the terms which comes into the random error. So let the observations of an experiment are A1, A2, A3, A4 and A5. Okay, or you take it as AN, A5, so on AN. N observations of an experiment we have taken. Okay. After taking these observations, to remove the random error, we have to find out the arithmetic mean as I explained you. Okay. So what will be the true value? True value, it is represented by A bar, will be equal to A1 plus A2 plus a3 and plus so on plus an divided by n. Okay, we have to take the arithmetic mean of these observation, and arithmetic mean of these observation is called true value. So this was the true value. After finding the true value, we have to find out what can be the absolute error. Absolute error is the difference between observed value and true value. So write here absolute error. Absolute error. What is absolute error? It is the difference between observed value and true value. Okay, so difference between observed value and true value, it is called absolute error. What is observed value? Observed value, we are having a1, a2, a3, a4, a5 and so on, an. So absolute error is represented by delta A. Delta A1, it will be A1 minus A bar. Delta A2 will be equal to A2 minus A bar, and so on. In this way, we will find out delta An will be equal to An minus A bar. Okay. So these are the absolute error that we got from the difference of observed value and true value. Okay. After finding the absolute error, we have another term that is called mean absolute error. Mean absolute error. Mean absolute error. What is mean absolute error? It is the arithmetic mean of positive value. This you have to remember. Positive values of absolute errors. Okay. So whatever absolute errors you got from the last one topic, of their arithmetic mean, positive value of theirs, arithmetic mean will be called mean absolute error. So how we are representing mean absolute error? It is delta A bar, and we use mod. Mod means we have to take only the positive value, because A1 might be greater than or less than A bar. Okay, the observed value may be greater than or less than the true value. If it will be less than the true value, then their difference will be negative. If that will be greater than the true value, the value will be positive. But when we are finding out the mean absolute error, we have to take only positive value. So for positive value, I am putting here mod. So mod A1 plus mod delta A2 plus mod delta A3 and so on plus mod delta An divided by n. So this is called mean absolute error. So next comes relative error. Relative error, or we call it fractional error. Fractional error. Okay. So what is relative error and what is fractional error? It is the ratio of mean absolute error to the true value. Okay. So relative error or fractional error will be mean absolute error, that was delta A bar upon A bar. Okay, this ratio is called relative error, and then afterward it comes percentage error. So what is percentage error? Product of relative error and 100. Okay, product of relative error to the 100 is called percentage error. So how to write the percentage error? Percentage error is equal to relative error into 100%. In percent we are writing this. Okay. So after an experiment, these are the steps that we have to follow. Okay. First we need to find out the arithmetic mean, that means a true value. After finding the true value, we have to calculate absolute error. After finding the absolute error, mean absolute error, then after relative error, then after percentage error, and at the last we need a result. So how to write the result? How we are writing the result of an experiment? So what will be the result is equal to true value plus minus delta A bar, mean absolute error, you can write here. Maybe you can write the percentage error also. Okay. So a value can be varied with the addition of this one or with the subtraction of this one. Like I'll explain you with an example. Like we are going to purchase a convex lens and I need a convex lens of 10 centimeter. I'll not speak him to give the lens of 10 centimeter. I'll speak him, give me the lens of focal length 10 plus minus 0.5 centimeter. That means its focal length can be vary from 9.5 to 10.5. Okay, 9.5 to 10.5. Clear? It will not be exactly 10 centimeter because nobody can make the things accurate. Okay, there will be slight variation in the instruments. Okay, these slight variation we are showing with this absolute error. Okay.
Do self-study at home and stay home, save lives. Thank you very much.